Howdy, I'm Zoe Cottrell, and I'm going to explain some of the principles behind how our demonstration works. So first off, with an electromagnet, in just normal magnets, there's kind of a sea of electrons, so they're not magnetized, but when you pump a current through it, it polarizes and pushes the electrons to one side so that you get a magnet. And then with this, we have a solenoid, so it's wire wrapped around a pipe a bunch of times. And with a solenoid, which is a specific type of electromagnet, the more turns you have, the stronger the magnet's going to be, but also the more current you're going to have to pump through it, which is one of the problems we encountered. But yeah.
Howdy, I'm Jordan, and I'll be explaining some interesting stuff for y'all. So, these are some of the materials that we used for our Lorentz Levitator. This is our resistors that we use for our system. We have diodes, LEDs, really colorful, transistors, and the main component, a Hall effect sensor. So with a Hall effect sensor, as you can see, they're very small. They have 3 wires connected to them that go into our breadboard system. The Hall effect sensor itself, it detects a magnetic field whenever a magnet gets close to the Hall effect sensor. If a transistor is connected to the Hall effect sensor, it turns off the current in the system. And so with this magnet and the Lorentz Levitator, the magnet will get close to the Hall effect sensor because of our electromagnet that is powered. And once that transistor detects the Hall effect sensor, it turns off the current and the magnet falls. Once the magnet falls away from the Hall effect sensor, the electromagnet will turn back on and it will pull back the magnet, and then the Hall effect sensor will turn it back off, and it'll start oscillating pace, making a levitation system.
Howdy, my name is Jamie Controlla, and today I'll be explaining the problems we have with the system. So in order to actually turn on the system, we just put power on, and we want to have it around like 8 or 9. And this is the breadboard of the system. So this is the transistor. This connects to the Hall effect sensor. And actually demonstrating it. So down here, you're able to see that it starts wanting to vibrate because it's trying to oscillate in place. That's the problem we initially had with it, that it doesn't oscillate fast enough. Okay, and if we go to the actual thing over here, you could see the Hall effect actually working. You could see the amps over here. If I move it closer, it goes completely flatlines, and I move the magnet far away. Okay, and the way we actually got to work is just by upping it a little more. And what we're able to do now is just actually make it sort of levitate along the tape. And it's just floating there.